Integrals of some particular functions. First one, dx upon x square minus a square. So for this, we factorize the denominator. So this will be x minus a times x plus b. We write 1 upon 2a integration. We write here 2a dx divided by x minus a times x plus a. Let's introduce x. So this will become 1 upon 2a, and then we can write here x plus a minus x minus a. Effect will remain same because x will get cancelled and a and plus a will remain 2a. Whole divided by x minus a into x plus a and times dx. Now divide it separately. So 1 upon 2a integration x plus a will cancel out and we will get 1 upon x minus a dx. And keeping 1 upon 2a outside, and the second will become dx divided by x plus a, because when it is divided by this x minus a divided by x minus a and x plus a, so x minus a will cancel out. Now we integrate it. For integration, let's consider separately. Suppose dx upon x minus a is given. Let x minus a equal to t. We differentiate it, so we will get dx equal to dt only. So it will become integration dt upon t, and that will give log t. So first term 1 upon 2a, and it will become log t minus. Similarly, if we consider second term integration dx upon x plus a, and we put x plus a equal to u, then dx equal to du. So this term will become du upon u, and du upon u will be log u. So second term will be log u plus c. We apply the property of log. So log m minus log n becomes log m upon m. So log t divided by u plus c, but t equal to x minus a and u equal to x plus a. So our answer will become integration dx upon x square minus a square equal to 1 upon 2a times log of x minus a upon x plus a modulus plus c. Now let's consider second one. So second one is integration dx upon a square minus x square. So this will become integration dx upon a minus x times a plus x. Let's again introduce a and x in numerator. So first we write 1 upon 2a here, and then 2a dx divided by a minus x times a plus x. So we further write 1 upon 2a integration. Here we write a plus x plus a minus x. Total effect will be 2a, x will cancel out, divided by a minus x times a plus x times dx. If we divide separately, means a plus x divided by a minus x times a plus x, then a plus x will cancel out, and in denominator a minus x will be left. So 1 upon 2a integration, we write the bracket here, or we can write bracket inside. So here it will become dx upon a minus x. And second one will give dx upon a plus x. Now let's integrate these two terms separately. Integration dx upon a minus x. So let a minus x equal to t. So if we differentiate it, so it will give minus 1 and then dt upon dx. So minus 1 dx equal to dt, or dx equal to minus dt. So it will become minus dt upon t, which will be minus log t. And second one, if we put a plus x equal to u and we differentiate it, 1 equal to du upon dx, or 1 dx equal to du, or dx equal to d. So here in second term we will get du upon u, and that will be log e. So what we have got from here, so we have got 1 upon 2a, and this gives minus log t, and this gives plus log u plus c. So log m minus log n will become log m upon n. So 1 upon 2a log u upon t plus c. We put the value 1 upon 2, 1 upon 2a, and the log. What is u? So here u is a plus x. So modulus a plus x divided by t is a minus x plus c. Now let's go to third part. So third part says integration dx upon x square plus a square. Here we can make substitution. Let x equal to a tan theta. So if we differentiate it, so it will become 1 equal to a sec square theta d theta divided by dx, or dx becomes a sec square theta d theta. So we replace these values here. So dx becomes a sec square theta d theta divided by x equal to a tan theta. So it will become a square tan square theta plus a square. That is a sec square theta d theta integration divided by a square common tan square theta plus 1. That is also sec square theta. So here 1a will cancel out. So 1 upon a integration sec square theta d theta divided by sec square theta. The sec square theta will be cancelled. So 1 upon a integration d theta, and d theta will give theta 1 upon a theta plus c, where theta can be found from here. So if we write tan theta, so tan theta will be x upon a, or theta equal to tan inverse x upon a. So 1 upon a tan inverse x upon a plus c. So we have got integration dx upon x square plus a square equal to 1 upon a tan inverse x upon a. Now let's see next question number 4, for integration dx divided by root of x square minus a square. Here again we have to make substitution. So let's write x equal to a sec theta. Now we differentiate. So it will become dx equal to a sec theta tan theta times d theta. or 1 equal to a sec theta tan theta d theta upon dx, and that dx is equal to LHS. So we put the values. So dx is a sec theta tan theta d theta divided by root of value. So it will become a square sec square theta minus a square, and we know that sec square theta minus 1 equal to tan square theta. So it will become a sec theta tan theta d theta divided by a tan theta. Why? Because we can take a square common, then sec square theta minus 1 will be left. And when we remove square root, so it will become a tan theta. So tan theta will cancel out. A will also cancel out. So now we are left with integration sec theta d theta. So in order to differentiate it, sorry, in order to integrate it, we have to multiply and divide by sec theta plus tan theta. So sec theta times sec theta plus tan theta divided by sec theta plus tan theta and d theta. If we take sec theta plus tan theta equal to t, sec theta plus tan theta equal to t, we differentiate it, so it becomes sec theta tan theta plus sec square theta times d theta equal to dt. And in the numerator, we have sec square theta plus sec theta tan theta. So it will be replaced by dt. So integration dt upon t, which will be log t plus c, where t equal to this thing, sec theta plus tan theta. So we have got log of sec theta plus tan theta plus c. Now, further, here we have to replace sec theta and tan theta in terms of x and a. So from here we can write x upon a equal to sec theta, and sec theta is hypotenuse upon base. So x upon a. So this would be equal to x square minus a square. So, and this angle is theta. So, what do we get? So, we get integration dx upon root of x square minus a square equal to log of sec theta. Sec theta will be same x upon a plus tan theta. Tan theta will become root of x square minus a square upon a plus c. Here, this can be written as log x plus x square minus a square under root minus log a plus c. Why? Because a is common, and then log m divided by n becomes log m minus log n. So log a we can write outside, and we can combine these two and write it as c1, because this is constant, this is constant. So our answer will be log of x plus root of x square minus a square plus c1, which is our answer. Thank you for watching.